Vitamins have long enjoyed a spotless reputation, seen as the natural, harmless antidotes to disease and degeneration. Pop culture and even many health professionals have often framed them as universally beneficial, with phrases like, "You can't have too many vitamins," echoing from kitchen counters to clinic waiting rooms. But modern research is painting a more nuanced picture, especially when it comes to the cardiovascular system. It turns out that certain vitamin metabolites, particularly when generated in high concentrations from excessive supplementation, can quietly stir the pot of vascular inflammation. Far from being passive helpers, some of these compounds may actively contribute to endothelial dysfunction and the early stages of atherosclerosis. And one of their favorite ways to do this? By flipping the molecular switch that upregulates VCAM-1. VCAM-1, short for vascular cell adhesion molecule 1, is like a molecular welcome mat for trouble. When overexpressed on the surface of endothelial cells, which line the blood vessels, VCAM-1 invites circulating immune cells, like monocytes and lymphocytes, to stick around and infiltrate the vascular wall. That's not a warm hug. It's the beginning of an inflammatory cascade that can lead to arterial plaque formation, impaired blood flow, and eventually cardiovascular disease. VCAM-1 doesn't rise for no reason. It's triggered by inflammatory signals, oxidative stress, and more surprisingly, by certain vitamin-derived metabolites. Take nicotinamide, for instance. It's a metabolite of vitamin B3, niacin, and under normal conditions it plays a vital role in NAD+ synthesis, cellular repair, and energy metabolism. But in excess, especially when the body metabolizes large pharmacologic doses of niacin, it converts into byproducts like 1-methylnicotinamide, MNA, and 4-PY and methyl, 2-pyridone, 5-carboxamide. These compounds, once dismissed as inert, are now under scrutiny for their pro-inflammatory potential. Studies have shown that elevated levels of MNA and 4-PY can increase the expression of VCAM-1 and ICM-1, another adhesion molecule, on vascular endothelial cells, essentially creating a red carpet for inflammatory cells to enter and stir up trouble in arterial walls. Even vitamins traditionally viewed as antioxidants aren't immune from the inflammation paradox. Vitamin E, for example, is celebrated for neutralizing free radicals and protecting lipids from oxidation. But when taken in high doses, especially in synthetic forms like alpha-tocopherol alone, it can disrupt the balance of other tocopherol isoforms and paradoxically increase oxidative stress. This, in turn, may provoke the expression of VCAM-1, especially in vascular environments already burdened by other inflammatory stimuli like smoking, high blood sugar, or hypertension. In some contexts, high-dose vitamin E has even been linked to increased all-cause mortality and hemorrhagic stroke, hardly the legacy of an antioxidant hero. Then there's vitamin A, or more specifically its active metabolite retinoic acid, which is well known for regulating gene expression. At physiological levels, retinoic acid helps maintain immune balance and cellular differentiation. But at high doses, it takes on a more aggressive personality, capable of upregulating adhesion molecules and pro-inflammatory cytokines in vascular tissues. Some experimental models suggest that excessive retinoic acid can increase VCAM-1 expression and amplify the inflammatory tone of blood vessels, a direct contradiction of its usual anti-inflammatory branding. So what's going on here? It seems that many vitamin metabolites interact with nuclear receptors, like PARs, RXRs, and NF-B pathways that regulate inflammation, oxidative stress, and immune signaling. At low doses, this interplay is tightly regulated and beneficial. But flood the system with high concentrations of vitamin metabolites, and those same regulatory pathways start misfiring. It's like giving a helpful intern too much responsibility too fast. They might mean well, but soon they're setting the office printer on fire. In the case of blood vessels, that fire takes the form of endothelial activation, leukocyte recruitment, and eventual plaque buildup, all of which stem from a process that started with a harmless supplement. What makes this especially problematic is that VCAM-1 doesn't act alone. It sets off a chain reaction. Once immune cells adhere and transmigrate into the vascular wall, they release cytokines, generate reactive oxygen species, and encourage smooth muscle cells to proliferate and form fibrous caps around lipid-rich cores. That's textbook atherosclerosis, and it can all begin with a little too much nutritional enthusiasm. So, ironically, in trying to avoid heart disease by maximizing vitamin intake, some people may actually be lighting the inflammatory fuse that leads them straight into it. None of this means we should fear vitamins. They're essential for life, and in the right doses, they help protect against a wide array of diseases, including cardiovascular ones. But the lesson here is about dose and context. Taking a vitamin to correct a deficiency is very different from flooding the system in hopes of supercharging health. More is not always better, especially when you're tinkering with metabolic pathways and gene expression in tissues as delicate and vital as your endothelium. So the next time you reach for that megadose multivitamin or pop your fifth antioxidant capsule of the day, consider this: your blood vessels may be quietly mounting a protest. Instead of being soothed by your good intentions, they could be raising VCAM-1, rolling out the red carpet for inflammatory guests and setting the stage for long-term damage. It's not a vitamin conspiracy, just another reminder that in biology, balance isn't just ideal, it's everything.